This is Britt Caswell with another example video. This is example 3 from lesson 1-6 in the SavvasRealize Algebra 1 textbook. In this video we are looking at solving a compound inequality involving AND. Alright, so when we have an AND inequality, we are making sure that our solution set solves two different inequalities. So it has to work for both of them. So a lot of times AND inequalities, they squish together into a single inequality when really there are two. So what I'm going to do is I'm actually going to break this into two inequalities. So my first inequality is going to say negative 12 is less than or equal to 7x plus 9. And then my other inequality is going to say 7x plus 9 is less than 16. And we're going to go ahead and simplify both of those. So I always start by drawing my river down my inequality symbol. That reminds me to use my inverse operations to help me to solve. So on this blue one, I want to get x by itself. So here where there's the plus 9, I'm going to subtract by 9 using that inverse operation to get rid of it. So negative 12 minus 9 is negative 21. It's less than or equal to 7x. And then when you have a number and a letter squished together like this, that's multiplication. So the inverse operation is division. So I'm going to divide by 7. And you get that negative 3 is less than or equal to x. Okay, now normally I like to have my variable on the left-hand side and my number on the right. So I'm just going to pick this up and flip everything around. So I'm going to say that x is greater than or equal to negative 3, because I think that's a little easier for me to graph. Alright, now on the yellow side, okay, we're going to follow the same order of operations because you see that it's the same problem, okay? So first we subtract the 9 to get rid of the addition. So I get that 7x is less than, and then 16 minus 9 is 7. And then we need to divide by 7 to get rid of the multiplication. And I get that x is less than 1. So these are my two inequalities. Now remember, in this AND situation, when we have this compounding, we need to have solutions that satisfy both of my inequalities. So what I'm going to do is I'm actually going to graph the inequalities just slightly above the number line until I've decided what it should look like. So this blue one, I know I need my point at negative 3. I know that it has to be filled in because it can be equal to right here. There's me filling it in. And x is greater than that negative 3, so I would be shading to the right. So in my set of solutions, everything bigger than negative 3 is an answer. Now for the yellow one, I know I need a point at 1. So there would be my point. Now it would be a hollow point because it can't be equal to. This just says less than. And then if I were to shade less than that 1, I would shade to the left. Now my solution set, so what I would graph on my number line, is only the values that would work for both the blue and the yellow. So like over here, the blue isn't covering the yellow either, so it doesn't work. So what it does is it creates kind of this Q-tip shape. So I can keep my endpoint at negative 3, and it's going to be shaded in because that satisfies both of them. And then here at 1, I'm going to put an endpoint at 1, but it's going to be hollow because it's hollow for the yellow one. And then I'm going to shade all the numbers in between. So that's where we get that like barbell shape. Now sometimes with compound inequalities, especially the and, instead of writing it as a single inequality, they might write it as two inequalities and then put the and there, and that's okay. So let's go ahead and let's try example 2. Or I'm sorry, number 3. I don't know how their numbers work, okay? So here we go. So we have negative 2 x plus 1 is less than 4. And we have 4x plus 1 is less than or equal to negative 3. Alright, so we are looking for the set of numbers that satisfy both the orange and the green. Okay, so I set my rivers down my inequality symbols so that I know that I need my inverse operations. Alright, first on this orange one, I need to use the distributive property to get rid of my parentheses. So negative 2 times x is negative 2x, and negative 2 times 1 is negative 2. And then I need to get rid of my addition or subtraction, so I'm going to go ahead and add 2 so that it's no longer on the left-hand side. So that leaves me with negative 2x is less than 4 plus 2 is 6. And when I have a number and a letter squished together, this is multiplication. So to undo that multiplication, I'm going to divide both sides by negative 2. Now remember, when we go to divide, if you multiply or divide by that negative number, this inequality needs to change direction. So instead of it saying less than, now it's going to say greater than. So make sure that you do that flip or you're going to get your answer wrong. So I still have my x, and then 6 divided by negative 2 is negative 3. And we'll graph that here in a minute, but let's go ahead and let's solve the green one first. That way we can do all the graphing together. This one's nice, it doesn't have any parentheses. So right away we can get rid of this addition by subtracting. So this turns into 4x is less than or equal to negative 3 minus 1 is negative 4. My number and letter squished together, that's multiplication. So the inverse operation is division, so I'm dividing by 4. So I get x is less than or equal to negative 1. So now I'm going to go to my number line. Okay, I'm going to want some numbers around negative 3 and negative 1. So this yellow, orange, whatever color this is, I know I'm going to have an endpoint at negative 3. It's going to be a hollow endpoint because the inequality doesn't have an equal to symbol. And then to shade x is greater than all that, that would shade to the right. So now with the green one, I know I need an endpoint at negative 1. I know I'm going to fill in that endpoint because it can be equal to. And x is less than that negative 1 would shade to the left that way. Now this is an and inequality, okay? So my answers that I graph on here have to work for the yellow and the green. So it's where they overlap. So I have my yellow endpoint. It's hollow, so my endpoint here is hollow. I have my green endpoint, and it's shaded in, so my new one's shaded in. And all that stuff in between, because that's where my two graphs are overlapping. So this red one is my solution set. Alrighty, so that is compound inequalities involving and. Until next time.